Hi everyone, here is Team 70 and we will introduce the agent we use in the sequence game. The first agent we built is using the gradient-based first search. The second is the Monte Carlo tree search agent, and the final one is the neutral guided MCTS. Let's start with the gradient-based first search agent. The core of this method is the heuristic functions. It evaluates each action based on the patterns formed after doing it. For example, 4 chips in a row or the broken 3. Each pattern is assigned with a different score, where the higher value means the higher chance to form a 4 sequence. The agent considers both the offensive potential, which is the forming a new sequence, and the defensive value, which is blocking the opponent's patterns. It also considers the central control and the drafting the jack card first. Finally, it using the one step ahead and the beam search to do the forward planning. Here is an example. The red chip in the rectangle is the actions being evaluated. The agent scanned all 4 directions, and we can see a potential 4 chips in a row for red in the vertical direction and a diagonal thread from the blue. Both patterns are scored and contribute to the final heuristic value. We face several challenges. First, designing and balancing all patterns which are hard. The second one is the time limit. Combining the complex, the heuristic value with the follow-up expansion can easily cause the timeout. Even though the agent still shows a strong pattern detections, a good balance between the attack and defense, and lightweight forward planning using the looking ahead and beam search. Here is still room for improvement. For example, we could model trade actions better by evaluating what is the follow-up actions after trading. And we could also improve the forward planning by exploring multiple paths in the beam search. And finally, we could simulate the opponent's behavior.
Next, our second AI method, Monte Carlo tree search. The algorithm uses simulation-based planning for long-term strategic decision-making. Our grading search have two problems: myopic evaluation of immediate rewards and static scoring. No game phase adaptation. CTS use simulations for long-term evaluation and combines heuristic knowledge with statistical exploration. MCTS have 4 steps. Section use PUCT formula, expansion of new data, simulation with weighted row loss, and back propagation to update values. This circles until 0.9 second limit. Our selection uses prior guide UCT formula. Given reference exploitation, the second term has exploration. C equals 1.4. Prior is our heuristic circle. Alpha equals 0.5 for prior weight. We solved 2 challenges. Prior weight information created fast rule subclass for hidden cut. Time constraints simplify heuristic to directional chip counting for 0.9 second limit. Advantages is informal exploration, strategic rule loss, long-term planning. Limitation is no offense modeling, heuristic sensitivity, simplifying variation. The methods balance strategic depth with efficiency. Filter improvements richer pattern evaluation, game phase awareness, opponent modeling. MCTS overcomes greedy search limitations, establishing foundation for more sophisticated AI approaches in our sequence agent.
Hello everyone. In the sequence game, our initial Monte Carlo tree search works well but has 2 critical limitations. First is next opponent modeling. The AI can predict what the opponent might do, making it vulnerable to counterplays. Second, the simplified heuristics sacrifice strategy depth, limiting long-term planning. Our neural-guided MCTS, inspired by AlphaGo Zero, introduces deep learning to solve these fundamental problems. Our first innovation is the 5-channel style representation. We encode the game state at 5 10x10 grids. Blue captures my chips. Red shows opponent chips. Yellow marks available positions. Green highlights my sequences. And purple shows opponent sequences. This rich representation helps the neural network quickly identify threats and opportunities, far superior to traditional MCTS single heuristic evaluation. Our second innovation is the hybrid MCTS strategy. We combine MCTS strategy search with neural network predictions. The Puke's formula with C equals to 1 perfectly balance exploration and exploitation. Here's the key. If neural predictions fail, we fall back to heuristics, ensuring reliability within our 0.8 second time limit. This hybrid approach creates a more intelligent and robust AI for the sequence game.